Okay, congratulations, you made it through chapter 1. So on to chapter 2. 2.1, trigonometric functions of acute angles. We're going to kind of hit a little bit of SOHCAHTOA on this one. So your objectives for this section, I can find trig function values of an acute angle, and you'll be able to use the cofunction identities to solve trig equations. Doesn't that sound exciting? Okay, now this is one thing I'm going to ask that you guys do is that you're going to put this on a note card. Please do it outside of class, like while you're watching this video, not in the middle of class and make us all wait. So, right triangle based definitions, we are getting into this idea of the right triangle and a circle. So on this one, the side of length Y is called the side opposite to angle A. Side of length X is called the side adjacent to angle A, and the length R is called the hypotenuse. So we're going to do stuff that we learned last chapter, bring it into stuff that you really should have learned in geometry, and go from there. So let me bring this screen up a little bit. Okay, maybe bring this screen up a little bit. All right, let's try that again. My pen decided not to move, so I had to play with a little ball. Okay, so on this one here, again, we're going to kind of move from geometry into trig, kind of combine the two together of what you know. Oh, let's get rid of this. So, on here I have a right triangle. Here is our origin of a coordinate plane. Positive x value, positive y value, and we get some point way out here, xy. And what I want to remind you guys of is that way back, so what we've been doing, if I have an angle theta here, then this would be my y value, and this would be my x value. Which makes sense, x, y goes up and down, x, and this is our radius. But in geometry, we would have known this one as our opposite side. This would have been our adjacent side, and this would have been the hypotenuse. And I'm going to change my theta there to A since they're talking about A. So let's fix that. There, A. Now, for those of you going, wait, what are you talking about with this circle thing? Is I can draw a circle here easily, and you guys can see, there we go. There is my radius, and for this point, the fact that x does not go all the way out, it goes out to this point right here, and then the y value is only going up that far. You can see either way you look, it doesn't go all the way out to complete the radius. So I do want to point that one out there for you guys. So hopefully you can pay attention to what's going on over this thing here. But sine of A used to be y, or is y now, but we knew it back in geometry as our opposite side. Over our radius for trig, which was our hypotenuse before. Which makes cosecant, if you remember, cosecant is reciprocal of sine over, reciprocal of sine. We just flip this guy over. So hypotenuse over opposite. So here, let's get rid of the circle that's bothering me. And he's gone. All right, cosine, your x, which is adjacent, we now know. Just trying to put things together because some of you guys had no problem with this in trig. But you're having a little problem putting it together with, had no problem in geometry, but you're having a little bit of trouble putting it together. Secant, reciprocal cosine, so we flip this guy over. And then we have tangent, and tangent is y over x, or opposite over adjacent. And cotangent being the reciprocal, we take the fraction and flip it. So adjacent over hypotenuse. Okay, again, pause this or do whatever. This is what needs to go on to that card. Okay, so let's kind of put what we just did on the card, bring it into stuff that you kind of really already know. Suppose ABC is a right triangle with sides of length AB and C and right angle at C. Find the unknown side lengths using Pythagorean theorem, and then find the values of the 6 trig functions for angle A. Rationalize your denominators when applicable. Got to do this every single time. So I'm going to draw a little triangle here for you. Actually, I'm going to draw it on the grid. Still want this one. We're going to bring this guy out. And we're going to use a dotted line. To show the length. Now remember here we have angle A. So this would be little a. This is angle C out here. So this would be little c up here, which leaves this guy to be angle B. And this is a little b down here. Now in geometry world, you guys would have had just the right triangle, and you would play with just the right triangle. I suppose I can draw it to look like the other triangle. So this is still angle A, this is still angle B, and this is still angle C. And before this would have, for angle A, still looking at angle A, this would have been the opposite side. This would have been the adjacent side. And this would have been your hypotenuse. But now we call this one R. This one is Y. And this one is X. So we have A, we have B, we need little c. So Pythagorean theorem tells us a squared plus b squared equals c squared. So 3 squared plus 5 squared equals c squared. So 9 plus 25 equals c squared. So c squared would be 34, but we want the square root of this. So c is the square root of 34. So I'm going to remind ourselves, A is 3, B is 5. Kind of lost our paper, we have to go swing up and down for this. And they want you to find sine of theta, sine of A, cosine of A, tangent of A. So let's start there. Sine of A is y over r, a over hypotenuse, however you want to write it. I do need you guys to get into that y over r. Make sure you know that. But our y is going to be our a value. and x is our b value. So we get on this one 34. Y is 3, r is square root of 34, but we have to clean that up, and we get 3 square root of 34 over 34. Cosine being our x value, x over r, or b over the hypotenuse, gives us 5 over the square root of 34, which is 5 square root of 34 over 34. And then tangent is y over x, or in this case, a over b, opposite over adjacent, however you want to remind yourself of these, which gives us 3 over 5. Okay, over here I'm going to kind of squeeze in the cotangent, cosecant, and secant. Reciprocal of sine is cosecant, so cosecant of A. Don't flip this one over, flip the original one over. That way you don't have to worry about radicals anymore. Square root of 34 over 3. Done. Secant of A. Again, take this guy and flip him over. Square root of 34 over 5. And cotangent of A is going to be 5 over 3. All right. Now they say, now find the 6 trig functions for angle B. Now here's angle B up here. So we kind of remember these. So we have sine of B, which is going to be still, but we have to be careful. Grabbing it from a triangle, we have to still look at the fact that this angle is not in the same place as my x and y's. So we have to use the SOHCAHTOA idea. That we're looking at sine, it's got to be the opposite. So for angle B, this one is opposite, and this one is adjacent. Using the colors there so that you guys can see it. So I'm going to write it up there. Opposite over hypotenuse gives us this one, which is little b, so 5 over square root of 34, which is 5 square root of 34 over 34. Cosine of b is adjacent over hypotenuse, but this is the adjacent side, which is the y value or the a value, so 3. So this is 3 over square root of 34, which is 3 square root of 34 over 34. And then tangent of b equals still opposite over adjacent, so we look up here, it's 5 over 3. So just like the last one, I'm going to change colors to do the other 3. So here I have cosecant of b, which is reciprocal of this guy, so square root of 34 over 5. Secant of b, square root of 34 over 3, and tangent of b is 3 over 5. Now here's what I will really like you guys to notice is that all of my purple values are exactly the same and all of my blue values are the same. And it's because they're in the same triangle. So for A, my opposite side is the adjacent side for B. Therefore, sine of B is the same as cosine of A. Sine of A is the same as cosine of B. And my tangents are actually the reciprocals. My tangent of B equals cotangent of A, and my tangent of A equals my, oops, that should be cotangent. Let's fix that one. Cotangent. And I got to fix that then. All right. So I think that might be about enough to really drive you guys crazy, because we've got quite the long video here. So we're going to put this thing on, well, it's a 15-minute video, but the other one's going to be about 15 minutes. This is a lot to soak in.